Hello friends, this is Dr. Siva Nagaraju, Associate Professor from IARE. Today we are going to discuss FM generation. In FM generation, we're having two methods, but today we are going to discuss the direct method of FM generation. Now coming to the topic, so there are two basic methods of generating FM waves. One is indirect method or Armstrong method, and second one is the direct method or simply direct FM. So we are going to discuss about this direct method or direct FM. But before going to direct method, a brief introduction about this indirect method. So in this method, a narrowband FM is generated and frequency multiplication is next used to increase the frequency deviation to the desired level. Okay. And coming to this direct method, in direct FM generation, the instantaneous frequency of the carrier wave is varied directly in accordance with the message signal by means of a device called VCO, voltage control oscillator. So you know that Fi of t, that is the instantaneous frequency. Instantaneous frequency is proportional to the m of t. What is m of t? M of t is the message signal. Its value is which is equal to am cos 2 pi fmt. Okay. So this instantaneous frequency Fi of t, which is directly varied by using this VCO. So we are going to extend this equation by substituting m of t value, that is am cos 2 pi fm. So here you can write this delta f, which is equal to kf into am. Okay. So in direct method or parameter variation method, the baseband or modulating signal directly modulates the carrier. So the carrier signal is generated with the help of an oscillator circuit. So the oscillator circuit uses a parallel tuned LC circuit. So you can generate this expression by this parallel tuned circuit. So already you know the frequency of oscillation, that is omega c, which is equal to 1 by root LC. Omega c is the angular frequency. So here you can substitute this omega c value, it is 2 pi fc, then fc which is equal to 1 by 2 pi root LC. So the carrier frequency fc to vary in accordance with the baseband signal m of t if L or C is varied according to m of t. So this is a Hartley oscillator which is used to produce these oscillations. So there is a 10 circuit having L1, L2 and C of t. So this C of t is capacitance. So the frequency of oscillation of the Hartley oscillator is given by Fi of t, which is equal to 1 by 2 pi square root of L1 plus L2 into C of t. Now we assume that the capacitive component of the frequency determining network consists of a fixed capacitor shunted by a voltage variable capacitor. You can see this C of t value is C naught plus C into V of t. So that C of V of t, that is a voltage variable capacitor. What is the fixed capacitor, that is C naught. We can call as C of t, also called as instantaneous capacitance. So since C of Vt, E of t, which is equal to delta C M of t. So now C of t, which is equal to C naught plus delta C M of t, where C naught is the total capacitance in the absence of M of t, and delta C is the maximum change in capacitance. So substituting equation 2 in equation 1, we get Fi of t, the instantaneous frequency, Fi of t, which is equal to 1 by this 2 pi into root of L1 plus L2 into C naught of 1 plus delta C by C naught into M of t. So Fc, since Fc which is equal to 1 by square root of L1 plus L2 into C naught. So substituting this value, we get Fi of t, which is equal to Fc by square root of 1 plus delta C by C naught into M of t. So here we take this denominator into the numerator. So you can write 1 minus delta C by C naught into M of t to the power of 1 by 2. Okay. So here we can substitute or let minus delta C by 2 C naught, which is equal to delta F by Fc. Then you get this Fi of t, which is equal to Fc plus delta F into M of t. So again come to the previous slide. This is equal to Fc, and expand this equation by using binomial series, then you can get 1 minus delta C by 2 C naught into M of t. So in the next delta C by 2 C naught, which is going to substitute delta F by Fc, then finally Fi of t, which is equal to Fc plus delta F into M of t. So assume that for a modulating wave M of t of frequency Fm, the capacitance C of t is expressed as C of t, which is equal to C naught plus delta C cos 2 pi Fmt. So this is our C of t. Now substitute equation 3 in equation 1. Again, instant frequency Fi of t. So as usual, what we've done in the previous, now that derivation is going to similar. So Fi of t, which is equal to F naught divided by square root of 1 plus delta C by C naught cos 2 pi Fmt. So where Fm is unmodulated frequency of oscillation. So again, we can move this denominator value into 1 minus delta C by C naught cos 2 pi Fmt to the power of 1 by 2. So here also, using this binomial series of expansion, you can write 1 minus delta C by 2 C naught into cos 2 pi Fmt. So here also similarly, delta C by 2 C naught, which is substitute that value, that is delta F by Fc. You got Fi of t, which is equal to F naught plus delta F cos 2 pi Fm t. Okay, so again see this previous one, you can substitute Fi of t, which is equal to F naught into 1 plus this delta F by Fc cos 2 pi Fm t. Okay, and this is the figure what we going to generate WFM, that is wideband FM, the required frequency deviation. So we're having a VCO, voltage control oscillator, low pass filter, frequency discriminator, mixer, and this crystal oscillator. So by using this figure, we can generate WBFM. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.